Inverter.
Hi, welcome to clickmyproject.com. This video will lead us to the complete demo of XML query intentional answering support under the domain of data mining. Extracting information from semi-structured document is a very hard task and is going to become more and more critical as the amount of digital information available on the internet grows. Indeed, documents are often so large that the dataset returned as answer to a query may be too big to convey interpretable language. We describe an approach based on the tree-based association rules, mind rules, which provide approximate intentional information on both the structure and the contents of extensible markup language documents, and can be stored in the XML format as well as. This mind knowledge is later used to provide a concise idea that gist of both the structure and the content of the XML document, and quick approximation answer to the queries. By using this process, we have to achieve the intentional query answering support for the semi-structured documents. Next, we're going to see the flow of data mining for XML query answering support. For this one, first we need to integrate the dataset to create a semi-structured file. Both the structure and content for the XML file will be extracted from the dataset and stored into the database. Induced and root constructions based on XML documents are gathered and predict the root and subroot and the child elements for the XML document. Frequent storing of dataset will be processed the stored dataset into the XML file. So it will be generate the pre-processed XML file. Root and extended tar functioning will used to generate the tar files based on the tree association rule mining. This will be happen by using the root and the extended root. Next, we have to compute the transaction prediction to compute the support and confidence value. Support and confidence are based on the number of transactions presented in each items. It will be used to generate the tree association rule. Frequent mining classification is the classification of queries to generate the tree level of classified queries. Content retrieval is the process of query retrieving, so it will be the answering support for the query which was given by the users in the semi-structured XML file. Evaluation phase will be generated by the previous output. Evaluation phase will be computed the accuracy between the current document and the current query. Next, we are going to see the complete demo of XML query answering support. For this one, first we need to choose the XML file for our further process. Here I have to choose the tar.ds XML file for the input. Next I have to load this file into the database and move to the next level. So here I have to show the what are the tag elements are presented in this tree structured XML file. Next I have to apply the pre-processing level. This pre-processing will remove the null characters presented in the XML file. Next I have to show the XML file details. Here we have 100 member records in that XML file and also this root node for contact information. Next we have to split this file as a multi-document. Here I have to split this file as the personal.xml file. Next I have to provide the next level. Here I have to predict the each and every element frequent items. So here I have to predict the each and every tag element values frequencies. This will help us to predict the similarity measurement. So the frequent set will show the what are the elements are presented in the each tag elements. Next I have to apply the classification for the further process. In this one we have a support and confidence threshold values and generate the tar.ds file. So this will help us to predict the what are the online processes are available. Semi-tar construction will combine a semi-structured document and create a tree association file. Next we compute the classification queries. These queries helps us to predict the output for each queries. Here I have to provide the first class query and I have to apply the query and predict the answer. So this will be return the number of distinct selected items presented in the each data set. So next I have to apply the classification query too. So this will help us to predict the number of counting. So it will use to predict the number of countings in each and every items. So next I have to apply the classification 3 queries to predict the distinct item set. It will help us to predict the distinct items. So next we move to the next level to compute the cosine similarity range. Cosine similarity range will help us to predict the how many values are presented in this one. For this next one we have to apply the path-based indexing sector and to provide the intentional answering support for each element presented in each data. So here the tar view will use to generate the how many values are presented and how they are going to be visited. So in this graphs will shows the path between the each and every documents. By using this approach we have to apply the all the queries and we have to predict the which one is the suitable answer for our requested query. This will help us to reduce the computational time for the intentional query answering support. This process will lead for the semi-structured tar file. Thanks for watching.